Welcome everybody and thank you for watching through Inquisitive Kids. In this video, we will be going through um, some basic information you need to know before starting the topic for this lesson, which is itinerary problems using formulas. So itinerary problems are problems like catch-up problems, made-up problems, things that have to do with distance, rate, and time. And we've been covering different types of itinerary problems and their formulas. Yes, there are formulas. Ever since actually the fourth grade playlist. So I will be putting the links to all those previous lessons we've done on itinerary problems in the description down below. Itinerary problems are so important, right? So it's very important that you grasp the different fundamentals of distance, rate, and time. You know their formulas. You understand the concept. You know how to draw sketches and all of that. Ratios and all of that. So in this lesson, we're going to be focusing on itinerary problems using formulas. So it's going to be quite simple actually, because there's no ratios or anything. You just have to follow the formula and you'll get it. So first, let's cover our first key point over here, is to review the different values in ships and water problems. Yes, so in here we will be covering three different types of problems. We'll have ships on water problems. We'll be having circular tracks, where instead of going on a straight line, you have objects traveling along a circle. And we will also have escalator problems, which is kind of like ships in water, because I'm sure you've been on escalators. It's kind of like moving stairs that go up and down. So the first two highlighted in blue is on ships and water problems. There's going to be no information on circular track problems because I'm going to be covering all of that in the video, in the problem. Okay, so basically we have four different values over here, and we're going to study their relationships. In V over here, V stands for velocity. So a lot of times you'll see me write V at its bottom right corner. I'll do something. So this represents the velocity of the water. W stands for water. This is velocity of going downstream, velocity of just being in still water, and velocity of going upstream. So the ship's own speed in still water is right in the middle, right? So if you go downstream, which is going along the water, right? This is your boat and you're going down, you're going to be faster because you're not going against the current. You're going along the current. The current is carrying you, meaning you'll go faster. So this would be more. This would be the water speed plus the ship speed. So the water speed plus the ship speed is equal to the downstream speed. So if you have a notepad nearby, I highly encourage you to take a note and draw this sort of chart over here. Over here, this is subtract because the upstream speed, now you're going against the water, you're going upstream. So that would be your ship speed minus the water speed. Therefore, you go slower. All right, now let's look at the second key point, which is the water speed does not matter in more than one boat. So if you say have two boats, right? Two boats either go in the same direction or opposite directions, the water speed no longer matters because as you can see, there's going to be always a plus and always a minus. So those will eventually cancel out. It's fine if you still want to include the water speed. It's fine. It's just that in the end, it's always going to cancel out. Now, the third one, which is number 1 for our escalator problems. So again, you can think of the escalator as so-called a current, right? It's kind of like the escalator is a river, and if you're going along it, then you go faster. If the escalator goes this way, but your person, like you're trying to run up, well, I mean, suit yourself, but that would make you slower. You're going to have to try harder if you want to do that. Okay, so if you're going against the let's say current of the escalator, the number of visible steps in your entire journey would be the number of steps that you walked plus the number of steps it moved up or down automatically. And if you go along it, it would be the number of visible steps would be equal to the number of steps you walked minus the amount that it automatically moved down or up. So thanks for watching for Inquisitive Kids, and see you in the problem.